Hi everyone, welcome back to my channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing stacks topic, and today we will do the last question of the first pattern, which is monotonic stack, and the question name is maximal rectangle. So definitely we will read the problem statement, but let me tell you the prerequisite of this video that we have discussed already, and that problem name was the largest rectangle in histogram. So if you have not solved that question yet, so definitely you will not be able to understand this one as well. So it's a humble request for you all, please watch that video and then come to this one. So this problem says, as you can see, the matrix will be given 1 0 and you have to return the maximal area, and that area should be covered by only one digit and not with 0. Means if you see here, this we can call it as rectangle, correct? The area is 2. This also we can call it as rectangle, area is 4. This also we can consider it as rectangle, area is 5. And this is also a rectangle and the area is 6. And out of all, the maximal area is 6. But why I have not considered this one? Because here 0 came, so hence this length is not valid, and hence we will not consider that. But how can we solve it? Before that, first we will check the constraint, because if you are following my playlist, then you will be habituated to this. So the constraint here is mentioned, as you can see, rows and columns. Yes, number of rows and columns. So in matrix, definitely the size of the whole matrix depends on rows and column, that is nothing but row into column. So here the rows and column length is given 200, so when we will multiply the number of elements, correct, or you can say the size will be 4 into 10 power 4, correct? As one side is 200, so definitely 200 multiplied by 200 will become 4 into 10 power 4, correct? So number of n is 4 into 10 power 4, means n square code will somehow get submitted, but we have to optimize it. Let's see how. But first we'll check the brute force code. How can we think of it? Suppose I have the very small element, this, correct? So the very base case rule for any rectangle is, can I say ki first, so we have to check all should be 1, and then second condition is ki it should be a rectangle as well, correct? So we cannot think like you can say you cannot draw like this, correct? This is not a rectangle, hai na? So for a rectangle case, we have the corners point. So can I say if I am standing at here, so I will have some R1 and C1, means row and column. Similarly, if I am considering this one, correct? So for this also I will have R1 and C1, similarly for this, and then I can say yes, it is a rectangle for sure. Similarly for this one, I would have this and this. So can I say from R1 C1 to R2 C2, definitely this is a rectangle. And now the second condition which I have to check is every number inside this is 1 or not. If any such number is 0, I can say it is not a valid rectangle, and if every elements are 1, I can say it is a rectangle. So for brute force code, it's somehow clear, right? Like we are getting some clear picture. Is that ki what if from R1 C1, which is nothing but 0 0, means this one, okay? So from this one to a particular cell, let's say this one only, I can say no, it is a rectangle. Yeah, I can. The size is 1. Okay. So if I am saying R1 and C1, let's call it 0 0, and R2 C2 also we can consider 0 0 only, correct? Because this one size is at least a rectangle, correct? But how can we calculate the length and breadth? Why? Because for any area of rectangle we need length and breadth, right? So can I say on some number line, when I have from 1 to 1, how I actually calculate from R1 C1 to R2 C2? Can I say for length part, we always do R2 minus R1 plus 1? Yes. Similarly for breadth part, we do C2 minus C1 plus 1. So here also we can do similar, right? Which is R1 C1 is also 0 0, R2 C2 is also 0 0. So actually we want to calculate the area of the rectangle from 0 comma 0 to 0 comma 0. Basically here, like on this, so you will say it does not mean, like it means nothing, right? Here we do exactly R2 minus R1, correct? But when we want to calculate area for this, we actually meant to say ki it's like we are talking about a cell value. Here we are talking about the point, okay? There are two different things. So that's why we will calculate the length and breadth by this formula for this matrix, but on a number line we simply do R2 minus R1 and C2 minus C1. So I hope this part is clear. Okay, so with this formula, what, like to calculate area, what we can do, R2 minus R1 plus 1 multiplied by C2 minus C1 plus 1. Yes, very simple. Now we can get the what, area. Okay, first initially R1 and C1 was 0 0 and R2 C2 is 0 0. Now for this, so I have calculated. What for next time? Okay, so there are two ways. For next time, let's take this cell, because from R1 C1, like R1 C1 to R2 C2, this is still a rectangle, but this is valid or not, that we will check later. For valid condition, every number should be 1, correct? So next time R2 C2 will become 0 comma 1, correct? But in this case it is not valid. Yes, it is not valid. Okay, now similarly, can we go ahead with this same? I don't think so. Why? Because in between I have found 0 now. So why to go unnecessarily, because when we already know ki because of this 0 all the rectangle will be invalid. Okay, that is little bit of optimized you can say, but it's not yet optimal one. This is a brute force one itself. Okay, now next time 0 1 0 2 0 3, next time 1 0, can I say? So from R1 C1 means 0 0, next time this. Is this a valid rectangle? Yes, correct. Yes. Now next time this to this. It doesn't mean ki we are calculating like this. No, no. We want to run from 0 0 to 1 1, means this one. So again we have to check, like we have to run the 2 for loops to check every such elements which are 1 or 1, correct? Okay, so what are you thinking? What I am saying is, with a single R1 C1 we are running this R2 C2, means first time, second time, third time, fourth time, and so on, one by one to all this, correct? And when we are running our R1 C1 to R2 C2 also, from here to here, first so we have taken O of n square to take, like to decide R1 C1 and R2 C2. Again we are running 2 for loops from R1 C1 to R2 C2 to check every elements in between are 1 or not, correct? So further O of n square complexity, what? To check if that is O of n square or not, correct? Yes. Okay, but this was though for one R1. Yes. What? For single R1 C1 you have checked, like you have calculated multiple R2 C2, and in those R2 C2 also you again ran for O of n square to calculate or to check every such elements are 1 or not in between. Can I say this? Next time, now the R1 C1 was 0 0, next time R1 C1 will become 0 1. Now again for this you have to run your what, R2 C2, but can I check, like can I take R2 C2 this? No. Why? Because previously we have calculated from here to here now. So hence now in this case, next time we will start from this index itself and moving or going forward. Okay. Okay, got it. So basically in total it will be of O of what, n power 6. But in matrix, so row multiplied by column it becomes na. So here we are taking row into column 3 times. Okay, so it's total 3 into row into column, which is nothing but row into column was what, 4 into 10 power 4, and 3 times will become what, 3 times means 4 into 4 into 4 into 10 power 4 into 10 power 4 into 10 power 4, which will make 10 power 12, correct? And this is 16 4 64 into 10 power 12, and you know this will for sure give us TLE, because beyond 10 power 8 it will be slow, but for sure beyond 10 power 9 it will be TLE when our code logic is simple. Here it is very simple because we are calculating just the area, yes, but it will give us TLE. But let's see the code for this. As discussed, first we will calculate the row and column, and we will initialize a maximum area variable, and we will run 2 for loops to generate our R1 C1 as said. Okay, now as discussed, if that R1 C1, because it should not be the 0, correct? Because if it is 0, then no matter what rectangle we are deciding from here, as you can see here, suppose R1 C1 is this, correct? So if this one is 0 itself, then do you think R2 C2 we should choose anything else when I already know that this itself is 0? correct? So we should not take any such rectangle starting from this point. So hence we have written here ki if R1 C1 a matrix value is 0, then we will simply continue, or else R1 C1 is valid. Now what I want, R2 C2. Again, to generate R2 C2 we will run two for loops, one for R2, one for C2. Yes. Now once we generated R1 C1 and R2 C2, you remember, we will now another, like, you know, we will run two for loops again to check every such elements are 1 or not. If it is, means if that rectangle is valid or not, correct? So what I'll do, I have called the function here. In this we will send the matrix R1 C1 R2 C2. Now here in this function we are running our for loop from R1 to R2 and C1 to C2, and we are checking if any such index value is 0, means we can say that the rectangle is not valid. So hence no need to calculate any such area if this function returns false, correct? Yes. And if no such index found which has 0 value, means it has all 1 value, means that rectangle is valid, and hence the rectangle is valid, this function will return true to this if case. And if this is true, then we are only left out with calculation of area, that with the help of R2 and R1, as said, R2 minus R1 plus 1 will give us length, and C2 minus C1 plus 1 will give us breadth, and we'll multiply that area. And as we have to give the maximal rectangle of all such valid areas, so we have to just update in our max variable, which is max area, and at the end we can simply return the maximum area. As said, time complexity, as you can see, row into column will be taken for R1 C1, again row into column will be taken for R2 C2, and inside this again nearly only n square, means R1 C1 again, like two for loops, correct? So can I say, as calculated, R1 into C, like R into C has given us 4 into 10 power 4. So R into C and R into C 3 times, correct? So all are nested, as you can see. For every R1 C1 we are calculating R2 C2, and for every R1 C1 to R2 C2 you are actually running two for loops in the nested order. So hence it is 3 times 4 into 10 power 4, as said 64 into 10 power 12. So in front of you I'll run this, definitely it will pass, but when we will submit this, it will for sure give us TLE, because the time complexity is going beyond 10 power 9, correct? As expected, TLE. So how can we, reduce the time complexity? Okay, so when I solved this problem for the very first time, I thought ki, is this a graph variation? Because if you have not learnt graph, then it will be a little difficult to understand this. But if you have seen the graph now, graph actually has nodes and edges, correct? That is also a graph. But sometimes that we will learn in the graph also, ki a 2D matrix can also be considered as a graph. So when I saw this problem for the very first time, I actually got confused ki how someone can think of either it can be matrix or graph. But how someone can think of ki we can apply stack data structure here. But later on I got to understand, and that exact reason I'll tell you. Okay, so we have to check the area. Definitely if you know graph and you have solved the maximal island problem, remember, then definitely this is the same variation. But without graph logic also we can do that. Why? Because as discussed, like if you will solve as per the graph logic, the time complexity will be little more, but stack will be more optimal. Because in graph we have BFS and DFS pattern, and that will help us either to detect the connected components or the number of connected components for sure. But there you have to apply a special check ki that connected component is a rectangle or not, correct? Because as if you will send this in graph BFS DFS logic, then definitely graph will return 7 as an answer, correct? Because it helps you to calculate all such connected elements. But here too we have just count the rectangle one, so hence there in the BFS DFS you need extra logic. That is the reason we are going to do with the stack, and definitely the time complexity will be much more faster compared to the BFS DFS logic. But can we directly apply stack logic here? Because here too we are not using any, like we don't need to go back and track something, correct? Then how can we think of stack logic here? Okay, why I said the prerequisite is the maximal rectangle in histogram? The reason was, if like we all are seeing this as a matrix, that is the main reason behind it. That is the main problem. We are not able to identify what exact pattern we are following here. Why not to break it into small pieces? Means, let's break this. We don't know this part. Okay, we just know this one. Let's draw it in block forms. Means 1, 0, 1, 0 and 0. Can you tell me the maximal rectangle in histogram logic? If you saw that video, then only you will be able to recognize this. Okay, again I am saying, if you have not, please go and watch that video. Okay, once watched, you can answer this. So what's a maximal rectangle? Means what's the common area in this? Can I say 0? Of course, right? Is it 0 or is it 1? Maximal 1. 1. Correct. Okay. So if we have just this row, then 1 is the maximal answer. Okay. Now think of like this. Only this one. Forget about these many. So can I say this block is of size 2? This block is of size 2. This block is of size 1. This block is of size 1. What's the common area? Maximal area. This will give 2. This alone will give 2. This will give 2. And this bigger one will give 3. Can I say? So can I say the first 2 rows together gave me what? 3 as a maximal area? Correct. But wait. Why first 2? Then we are going in the 2D matrix only, na? But maximal rectangle was only possible with 1D. If you see this logic, don't you think in maximal rectangle, you just had an array of input like 2, 0, 2, 1, 1. That's it. Can I say 2, 0, 2, 1, 1. That's it. In maximal rectangle also, just to represent, they have given you the block, right? But input size, like input was integer array only. Yes. So if I'll give you, like if somehow we will be able to convert this 2D matrix in 1D, we can use the same logic to calculate the maximal rectangle. Now, let's forget the last one and let's calculate for this. Can I say 3, 1, 3, 2, 2. What's the common bigger area? Can I say this one? 6. Yes. So if I am standing here, what array I'll generate? Like for the previous one, it was 2, 0, 2, 1, 1. But now it will be 1, 1, 1, 3, comma 1, comma 3, comma 2, comma 2. What I did? Can I say this is nothing but prefix sum? Yes, yes, you are right if you are thinking that way. Correct. So if I can generate this 1D array, how many number of times? Number of row times. And using the same previous function which we used in maximal rectangle, we'll just send these arrays one by one. Correct? And once send the array, what maximal rectangle function did? It has given us the maximal area. So one time maximal area, one time maximal area, one time maximal area, one time maximal area, and out of all those 4, we can give the maximum one. Correct? And hence that we will get with the, like when we will send this third array. But why not 4th? Because obviously when we'll send this, this will give us 4, but maximal was 6. Okay? Because of this is 0, definitely we won't consider this 1. Don't get confused. We are saying, like, don't think like blindly we will just do add up here. Then to addition will be 1, addition will be 3, addition will be 3. No. If this is 0, then all the above weightage is not applicable. Correct? So here when you are calculating the prefix sum, the logic will be very simple. If it is 1, then you will just add all the above ones and add it. If it is 0, it will be 0 only. Means no calculation for that. We can write the logic now. So I have written the code already for you so that it will take very less time. So just calculate the row and column and make that integer heights array, which we will update for 4 times. Why? Because basically number of rows times, yes, maximal area, which is nothing but obviously we are initializing the variable. Now we will run the for loop for 2 times just to check if matrix of ij is equal to 1. Then we will just do heights of j plus is equal to 1. Basically we are doing the prefix sum here. First we'll fill this heights of j for what? Like first time we'll fill this, correct? So this will be 1 0 1 0 0, correct? And we'll send this in that function. Whatever that function will return, maximal area, that will count. Next time this we will update with what? 2, this 0, this 2, this 1, this 1. So now heights of j will become the same heights of j will get what? Updated with 20211, and that again we will send it. So as you can see, we are checking this. If it is 1, then we will calculate, but if it is 0, then we will not calculate, and height of that jth index will remain be 0. And once we are coming out of this inner inner for loop, that will actually give us the heights of j array. Okay, that j heights of j array, like heights array, we will send in that largest rectangle function, which we already discussed in the previous question, and that function will give us the maximal area, and we will just keep on updating in the max area variable, and that's it. This largest rectangle code we already discussed in the video, again suggesting please go and watch that video, and please do let me know till here if you understood the brute force code, optimize, and also the reason why we have not thought of graph here, because of the complexity of course, and why we can think of stack, because we broke down, this was the previous pattern based problem which was maximal rectangle in histogram, yes, and that we already learned ki why we'll use stack there, and that's it. So let's run this code and let's submit, let's try to submit. And if you want to calculate the time complexity here, definitely we'll see. First we are taking 2 for loops, which is row into column, to generate the prefix sum. Yes, so time complexity will be row into column, which is 4 into 10 power 4. And inside this now, like to calculate the largest, definitely this function which is checking for maximal rectangle. Here if you see now, which we already discussed in the previous video, but this for loop, and inside this a while loop, but this is not running for every I, we are not running the while. Okay, so in total the while loop will run for only O of n, means for entire for loop iteration O of n, means in total O of 2n, which is linear only. Okay, and here row into column, correct? So hence in total row into column for this, and as if you see now, this heights area only you are running this, correct? So heights area, like heights length is nothing but number of column, row into column, inside this you are calling this nested, correct? So it will be in multiplication, so row into column into column. Okay, that's what will be the time complexity here in this case. And space, definitely we are using this maximum area of size columns, but we are updating also, correct, for row number of times, so that's why row into column will be the space complexity. And that's it. As you can see, it has been submitted. So if you understood this, we can go in our sheet and we can mark the question as done. But wait, we just I just showed you the Java code, right? So here the same approach. Here is your Python code if you are from Python background, correct? It's a similar logic, first prefix sum and then the largest rectangle area. And here is the C++ code if you guys are from C++ background. Same approach, only the code differs, and I hope you guys all have submitted this. If yes, please do let me know in the comment section that you have submitted this. And if in case you guys are new to this channel, we are following this pattern wise DSA sheet. You can check the links from the bio. And a humble request guys, if you guys are liking the way of explanation, please do hit the like button and subscribe the channel if not yet subscribed. And that's it for this video. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family.